All right, guys, there we got some scatter plots. Let's take a look. When you look at scatter plots, they're basically graphs of real-life data. Very few times do real-life data or number sets actually fall into straight lines or perfect curves or anything like that. They're pretty much scattered. We're going to name 3 of these based on how the points fall. This first one is the dots. It looks like it has a positive slope, or it's going this direction. Rising left, right. We're going to call that a positive correlation. And if the points are close to a line, the closer to a line, the better the correlation. Like these points, if I drew a line right through there, it'd be pretty close to hitting several of them. That means it's a pretty good positive correlation. Same thing with the negative going the other way. If I draw a line right through here, that's not a great one, but I can still get kind of close to a bunch of them. And because it's falling from left to right, we call that a negative correlation. And if they're scattered everywhere like this, you can't draw a line if you wanted to. We could call that approximately no correlation whatsoever. They're not even related to each other. Okay, we're going to use the letter R to tell us. It's called the correlation coefficient. It's going to tell us how closely related our 2 number sets are. R is always between -1 and +1, and the great thing about R is the closer it is to -1 or 1, like if it's 0.99 or -0.97, 0.96, something like that, that means there's a really strong correlation. If it's close to 0, let's say it's 0.02 or 0.3, something like that, that means this correlation is very weak. So the closer to -1 or +1 for our R, and I'll teach you how to get the R tomorrow. We're going to do that on the calculator, and I can't really show you that on a video so well, so I'll show you that in class tomorrow. But we're looking for an R between -1 and +1, and the closer to -1 or +1 it is, the better the correlation or stronger the correlation. All right, the first kind of problems you're going to do are tell the correlation coefficient, which is R, is close to -1, -0.5, 0, 0.5, or 1. This first one right here, I would probably say 0.5 because you could possibly draw be -0.5. Because you could kind of draw a line, not super close, but a little bit close. This one right here, very scattered. I'd say close to 0. And then this last one, you could draw a really good line right through there. So I'm going to say that R would be very close to +1. Okay, I hope that helps a little bit with what we're talking about on the last slide. Okay, one thing we're also going to find is what the equation of the best fit line. Like there's one line that is the best to represent this data, and I'm going to try to draw one. It may do something like this, where I may hit a couple of points, but I'm trying to come as close to all of them as I can. Now, the great thing about finding that best fit line and finding out exactly where it is, are you ready for this? The calculator will give it to us. Okay, so that's where we're going to go tomorrow. Again, I'm going to show you how to find the best line you can by using your calculator. And I just said this, but we'll use calculators to find an R and the line of best fit tomorrow in class. So you need, oh my gosh, please make sure that you have them tomorrow. Bring your calculators with you. If you don't, I don't know what, you're just going to have a hard time. So make sure you got your calculator. We'll work on this tomorrow. Have a great evening. See ya.